Hello and welcome everyone to today's webinar. My name is Ethan Donald and I am the CEO of ExactFlat and I'll be your host for the next 30 minutes. This webinar is brought to you today by ExactFlat and our topic is how do you create 2D flat patterns from complex 3D designs of carbon fiber parts. And we're talking about any type of carbon fiber part, including auto parts, energy parts, aerospace parts, marine, railway parts, and various types of consumer goods. Demand for carbon fiber and related products is forecast to continue to grow substantially. The winners in design and fabrication efficiency are going to win more customers. The workflow we're going to show you today is all about design and fabrication efficiency, so you can win new customers. In this webinar, you will learn the full 3D to 2D digital pattern making workflow, including preparing 3D layups and pattern piece creation, 3D to 2D flattening of complex double curved surfaces, and creating output files for cutting and documentation. We will be showing this process with a new product called CompositeFlat. CompositeFlat has algorithms designed specifically for carbon fiber materials. Our webinar today is approximately 30 minutes. Before we begin, there are a few housekeeping items. First, this session is being recorded, and we will provide you with a link so you can watch again or share with your colleagues. Next, the webinar is in listen-only mode. If you have questions, please post them in the Q&A feature located at the bottom of the screen at any time. Now that that's all done, let's get started. The goal today is to use a faster, more efficient digital process to create patterns for the fender of this motorcycle. We're going to create patterns with 3 layers and a 45-degree rotation on each layer. Pattern pieces with split lines defined in 3D, and lastly, a plybook for assembly documentation. The workflow has 5 phases: 3D design, meshing, which is a way of creating digital fabric, pattern piece creation, 3D to 2D flattening, and creating a DXF export. Before we demonstrate the workflow, let's look at the steps in more detail. Starting with step 1, you can import any design from any leading third-party 3D CAD product. You don't have to change your development environment. Simply export your file in a supported format, such as STEP or IGES. You can then import this design into CompositeFlat. You can also work with laser scanned inputs. You simply have to process your laser scans into 3D surface models with split lines, and then import into CompositeFlat. Lastly, you can design directly in CompositeFlat. CompositeFlat works inside Rhino 3D, which is fully capable of creating accurate multiply designs of your parts. In step 2, we create a new 3D mesh of the surfaces. The CompositeFlat 3D to 2D flattening algorithms will be applied to this mesh. Next, in pattern piece creation, if your offset layers and pattern splits have not already been designed into your parts, you'll be able to add them to your model in this step. You can also color code your pattern pieces for much easier management of your parts. Next, you do your initial flattening, then optimization of fit, followed by assigning your grain direction. This is important at this stage since it relates directly to fiber orientation. At this point, you're ready to create an output DXF file that can go directly to a cutter or to a 2D CAD program. Lastly, creating a plybook involves selecting your layer, choosing a layout, and annotating your file as appropriate. I am now going to demonstrate this process. As a reminder, if you have any questions, please use the Q&A feature and my colleagues will do their best to answer as we go. Our part is taken from the front fender of this motorcycle. It was designed in a third-party 3D CAD program and imported into CompositeFlat. We're going to focus on the front fender, a complex double-curved surface. I'm going to start by making our fender layer the default layer and hiding the rest of the bike. The next step is to create a mesh. First, we're going to switch over to the Meshing tab and select the ExactFlat Adaptive Remesher. This will help us create an optimized mesh for 3D to 2D flattening. If you want accurate patterns, creating a good mesh is an essential first step. You can see that we have a variety of controls over the mesh and in particular the type and density of mesh elements. The adaptive remesher makes mesh creation very easy and will create a mesh with smaller triangles around areas of higher curvature and larger triangles around areas that are flat. I'm going to play with the settings to demonstrate how the mesh changes. As we do this, you will notice how the edge boundary changes and the triangle themselves adjust. The overall goal is a smooth distribution of triangles across the surface, and this usually takes just a few clicks and is done in about a minute. You can see here the edge boundary has some angular elements to it, and we're going to adjust that by decreasing our desired boundary tolerance. Now the edge boundary is getting a little bit smoother, but let's go ahead and make further adjustments just to demonstrate how quick and easy it is to adjust the mesh. Now I'm going to adjust the surface tolerance. Now you can see we have more mesh elements, but the mesh does a better job at representing the surface. If you recall, pattern piece creation involves offsetting layers, inserting split lines, and color coding your pieces. These do not have to be done in this order, and they may not need to be done at all in CompositeFlat if they were part of your original 3D design. For our purposes, we're going to offset these layers and we're going to choose an exaggerated offset distance so that it will be easier to see what's going on. Our intention is demonstration of how we can eventually flatten these layers and not getting into the nuance of composite part design. To do this, we choose the Offset Surface command. 20 more layers are not uncommon for some parts. In these situations, the surface geometry changes enough such that once the surfaces are offset, the different layers will be flattened individually. We are only going to do 3 layers in this demonstration, but rest assured, if you produce more, you can flatten and create patterns for them all in the same way we are showing today. I'm going to create a new layer with a 3mm offset. As you can see, there is a good separation between the layers that will be perfect for our demonstration. This new layer will be the middle ply. I'll create another layer, and to do this, I'll right-click on my mouse to repeat the last command, and then create another layer with another 3mm offset. Now we have 3 layers. The next step in our process is to add split lines to our layers. I prepared our model in advance to do this. What I've done is created split lines. These split lines will then be projected onto the surface of the mesh and used to define where the mesh is to be split. I'll use the vertical lines for the first layer, the lines in the 45-degree angle for the middle layer, and finally the horizontal lines for the bottom layer. But what I'm going to do first is I'm going to take a few seconds to name the layers. This will make it easier to keep track when we start the 3D to 2D flattening and plybook documentation process. We'll call the first layer Layer A, the second Layer B, and the third Layer C. Now we are ready to do our splitting. To start, we select the Mesh Split command. Then we select the layer to split, in this case the outer layer, Layer A. Next, we select the two horizontal lines and hit Enter. The lines intersect with the layer and split the surface into 3 pieces. I'll repeat the process for the next layer. First, we select the Mesh Split command. Then, we select the layer to split. We'll select the middle layer, Layer B this time. And we'll select the lines on a 45-degree angle, and when finished, hit Enter. As before, the lines intersect with the layer and split the surface into the desired number of pieces. Let me just hide the top layer to make this easier to see. And there you can see our middle layer has been split into 6 pieces. I think you get the idea, so I will skip ahead now and move on to the next phase. Here, I have split all the layers in advance and color-coded each pattern piece. Now we're going to flatten them. If you have any questions about what we've covered so far, I would encourage you to use the Q&A feature and ask a question. My colleagues will do their best to answer.
Offset the original mesh, do our splits, and then remesh. For this shape, the shapes are simple enough that it's not going to matter, but I just want to mention that depending on the complexity of your part, it might be better to save remeshing for the very last. So you might want to do your offsetting and splitting first and then remesh, depending on your workflow. So at this point, we're ready to go ahead and start flattening. So we're going to at this point, we've covered our mesh processing, we've done our splitting. We didn't have to do any kind of mesh repairs to this model, so we've done our remeshing. We went back to our piece creation tab and we did our splitting. So we created a construction plane where we wanted to do our splitting. So at this point, what we'll do maybe is we'll just set this construction plane back to the world top using the world top icon here. And we created a construction plane, placed some splitting curves on it. That's the split lines here. And then we split up our meshes. We then renamed them and assigned unique colors to them. So at this point, what we're going to do is we're going to turn off our split lines layer. So now all we're doing is looking at our meshes, and we can go ahead and we can flatten this. So we're going to move over to our patterning tab, and we're going to use the first icon. This is the flattening icon, and we're just going to rectangle select everything here and press enter on our keyboard. And very quickly we end up with a flat pattern here. So we can see that our flat pattern colors have all been preserved. Not so much of the face color, but if you look at the color of the edge tessellation, it is the same. And what we can do is we can go to rendered, and actually rendered's not the best option here. So we're actually going to go to wireframe, and now we can really see the color of the meshes. Alternatively, we can go to shaded, and right now we're looking at the strain analysis, but we can toggle that off. So we can toggle strain or toggle stress, and that's going to turn off our strain highlight. So I'll right click to turn it back on because our strain highlight is a very important part of the process. So as soon as we flatten our pieces, they all end up on the XY pattern plane, and we can see we still have our 3D model here. So we're actually viewing both the original 3D model. So what we can do is we can turn that off. We're going to turn off our fender, and we're still seeing the 3D model. So when we flatten objects with ExactFlat, we end up with 2 new layers. We end up with the ExactFlat model layer. This is where our reference model is placed, and we end up with the pattern layer, and that's where our 2D pattern pieces are placed. So what we're going to do is for our current workflow, we're going to make our pattern layer the default layer, and we're going to switch off our model layer. We're going to be working with our pattern pieces for now. Right now our goal is to create production ready flat patterns. So we don't need our reference model at this point. So what I'm going to do is I double clicked the perspective title, that minimized the viewport, and now I'm going to double click the top view. We're going to maximize the top view, and we're also going to zoom to extend. So we're going to click that icon just to bring everything back into view. I'm just going to kind of move a couple of these pieces around here, and I'll click the zoom extents icon again, and now we've got a bit bigger of a view. So we're going to go back to our shaded viewport. As I mentioned, we do want to see the strain analysis, and if the colors of the tessellation are obscuring your view too much, we can turn that off as well using the EF toggle edge toggle mesh edges command, and then we can turn that off, and now we're just focusing on the piece boundaries. This is also a very useful way to spot any folds or wrinkles that may occur during the flattening process. You can turn off your edge highlights and your strain analysis, and it's a very easy way to make the folds or wrinkles just pop right out. But I don't think we have any folds or wrinkles. So ExactFlat, we've gone ahead, we've flattened using the flatten command, and really what this is we've just we've started the flattening process using one of ExactFlat's pre-flatteners. So ExactFlat is split up into a two-part flattener. Our first part being our pre-flatteners, and our pre-flatteners are very fast, very quick flattening algorithms that are designed to get you an unoptimized 2D flat pattern, and that's what we're looking at here. So when we look at these parts, we've got 2D parts, but they also have a lot of rainbow colors to them, and ExactFlat uses color to identify or indicate strain on the pattern piece. So the more color we have, the more it's shifting away from white towards red, the more strain we have on the piece. And really what that means is the more strain we have, the smaller the actual piece is. So we're going to have to stretch that piece to get it to fit back on. So our pre-flatteners, they are very quick flatteners that get you unoptimized flat patterns that often have quite a bit of strain. And our second flattener is our optimizer. That's the spring icon here. This is a much more accurate flattener, and it actually relaxes and relieves all the strain from the pattern piece to give you a production pattern. And it does that using the mechanical properties of the material. So whether you're using a cotton or for composites, a fiberglass or carbon fiber, some kind of weave, each material is going to have different mechanical properties, and ExactFlat simulates those mechanical properties during the flattening process using the spring tool. So first stage flattener is very fast, produces unoptimized flat patterns. Our second stage flattener, the spring, it takes a little bit longer to run, but it relaxes your patterns to production quality. There are a couple things we can do to reduce the amount of time required to flatten objects. So the adaptive remesher is the best strategy. We want to simplify the geometry as much as possible, but even after flattening, instead of just optimizing these pieces outright, what we're going to do is we're actually going to rerun a different pre-flattener. We can run our pre-flatteners as many times as you want on as many different pieces as you want, and in the case of some pre-flatteners, such as our fracture, both our smart fracture and regular fracture, the selection point actually does affect the pattern that's being produced. So fracture algorithms work extremely well on developable surfaces and on symmetrical pattern pieces. So we're going to go ahead, we're going to use our smart fracture, and we're just going to start clicking on our pieces here, and very quickly we can see these pieces are being reflattened here. So we're fracturing these pieces here, and as we fracture them, we're going to notice too that not only is the shape changing, but we're adding additional material and the colors are changing. So because we're adding additional material, our colors are changing away from red, they're moving more towards white, and in this case we actually have black on here, which indicates sag or an excess of material. So fracture is a very good algorithm for these pieces here, and it's working quite well for us. We also have different algorithms. This is our least square conformal map tool, and it's just a different algorithm for producing an unoptimized flat pattern. So we get different results with this one. We also have our pelt algorithm, which again gives different unoptimized flat patterns. We've got our relaxed curvature, which again, same thing, gives different unoptimized flat patterns. Our CCM algorithm gives unoptimized flat patterns. We're actually going to change our mode to initial here for this one. Minimal will attempt to remove folds or wrinkles while preserving the shape. Initial is the pre-flattener we would use to generate a new initial flat pattern. But judging from all of these, the results, last one here is our press, and press is actually what's used by the flatten command when we actually first flatten something, but it's probably the quickest pre-flattener, but it probably is the least reliable. So for these parts, our smart fracture algorithm probably works the best. We get by far the best results here with the least amount of strain. So our strategy going in is, first and foremost, we need to remove folds and wrinkles. We don't actually have any folds or wrinkles in this part because we've used our different pre-flatteners, and we've eliminated, there weren't any with press anyways. But if you did have a fold or wrinkle, you would notice, you would see a little plus icon on the toolbar. So I'm just going to go ahead, I'm going to manually distort this pattern. So I'm using our vertex manipulator, and I'm just dragging this out, creating a very obvious fold. So I've grabbed the corner and I've pulled it over. So I've folded the material on itself. And when I do that, we can see that we've got a little plus icon there that appears, and we've also got our inset triangles. So this is the highlight that appears on all triangles that are folded over. And these are errors, they need to be fixed. So when this happens, the easiest way to fix it is to simply run a pre-flattener. So I'll choose our smart fracture pre-flattener. I'm just going to rerun it here, and very quickly it removes the fold or wrinkle. Another way to remove the fold or wrinkle is manual vertex manipulation. So we can use our vertex move vertex tool, and we can just drag it back to a place where it's no longer folded or wrinkled. Our last method for fixing this is our automated flip triangle removal tool. This may or may not work depending on the severity of the folds or wrinkles. It may prematurely terminate. So it's going to tell you how many folds or wrinkles there were when it started and how many it was able to remove. But it's not always guaranteed to work 100%. But we can select our piece, press enter, and it's going to manipulate the folded triangles such that they are no longer folded. For this piece, our pre-flattener by far did the best job of removing the fold or wrinkle, so we're going to go ahead and use that again. Once you've removed all your folds or wrinkles and you have your pattern pieces, we can go ahead and we can optimize them. So we're going to go ahead, we're going to click the spring icon, and we're going to start selecting our pattern pieces here. And we'll go ahead and press enter. And at this point, we've got our material selection dialog. So we can also adjust the settings of the optimizer here. We're going to leave the defaults as is. And at this point, we can choose the material down here. So ExactFlat comes standard with about 80 different materials. So you can select through the list here, find a material that is closest to your needs. And once you select the material, you're going to be optimizing the pattern piece with the mechanical properties of that selected material. So I'm going to go ahead and I'm going to choose our carbon fiber material from the list here. And I'm going to go ahead and I'm going to optimize with carbon fiber material. So I'll go ahead and I'll click OK. And this is going to start the optimizer. So very quickly it's going to run. We can already see that the shape is slightly changing here. And more importantly, again, the colors are changing. So while we didn't have any strain in the pieces before optimizing, we did have quite a bit of sag, which can be a problem for composite parts. So the optimizer does both. It eliminates sag and strain, and what it really does is it tries to bring the average energy density to as close to 0 as possible. So when we look at the spring status report, we get quite a bit of information here. But the most important one is probably our average energy density. So the closer to 0 that value is, the closer to the perfect pattern we have. So generally speaking, any kind of value under 1 Newton meter is a pretty good pattern. For these parts, we've got around 0.2 Newton meters, which is extremely good. Something else we also want to look at is our no seam stretch error. So this is a global accumulation of the difference between the model perimeter length and pattern perimeter length for each pattern piece. So again, the closer to 0 that value is, the better. And we do have ways to further reduce that if the value is just no good. So we're going to go ahead, we're just about done here. We're going to let this finish up and then we'll move on. So at this point we have all our pattern pieces here, but it's not very obvious where they all go. Fortunately, we assign colors and names to all of them, so when we click on the pattern pieces, the name actually does carry through the flattening process, so we can see which piece is which. So we have C5, C6, C2, C3, C4, and so on. So we can very easily identify this is C1, and we know because we went left to right, top to bottom, we know that this is the top of the piece. When we start looking at the pieces themselves, we can see that we've got some of the edges are green, and this green highlight actually represents a seam edge or an automatic cut. ExactFlat has recognized that there was a cut or a division between two pattern pieces, so it's highlighting that for us. So knowing that, we can actually use this, and what we're going to do is we're going to rotate this piece because we went top to bottom. We know that piece C2 is going to be placed up here, so we're just going to use the Rhino rotate command, and we're going to choose our center of rotation, which is the end of this cut over here, and we'll pick this vertex over here to act as our first reference point, and we're just going to flip it around. I'm going to hold shift over here so our second reference point is perfectly horizontal with our center of rotation, and whoops, so we're going to undo that. I had copy turned on still, so we're going to repeat this. We're going to actually, first I'm going to redraw. So we're going to, once again, we're going to use the Rhino rotate command. We're going to turn copy no, and we're going to choose our center of rotation right there, our first reference point right here. I'm just choosing the end points of the automatic cut, and we'll rotate this down here like that by holding shift. Once we have our first piece in place, we can go ahead and use ExactFlat's find tool. So it's the binoculars icon here. So we go ahead, click that. We can set an optional offset. Right now it's set to 30 millimeters. And we're going to go ahead and just start selecting edges here, and it's going to automatically find the neighboring pattern piece, and it's going to move it and rotate it to the selected edge. So this is a very quick way to automatically, or not automatically, but it's a very quick and easy way to orient your pattern pieces so you know where they go. So next we're going to go ahead, we're going to find B1. That's this one right here. We'll move this over here. So again, B1, we know this was at the top, so we're going to go ahead, we're going to rotate this. Trying to rotate this one to the correct orientation might be a little difficult. So again, we're going to rotate here, and we think that I'm just going to eyeball this here. I think that's probably the top right about there. So we'll rotate it down like that. Now we can once again use our find tool, and I'm just going to click on our edges here. So using this on the 45 might be a little more difficult. So we're going to try to pick something in the middle. So hopefully we're going to preserve our up-down orientation of these pieces here. And we'll just manually drag and drop these back to where they should be. So I'm holding, just kind of dragging these, trying to get them perfectly vertical. So we're a little off. I can see we've got a bit of a tilt there, but that's okay. That's not a big deal. Lastly, we've got our A1, A2, and A3. So this is A3, that's on the right. This is A1 over here. So I don't know what the correct orientation of the middle piece is going to be. So I'm going to use A1 over here. We're going to rotate, and I'm going to use the end point down here as the center. We're going to use the other end point up here as our first reference point, and then we're just going to use the find command, and I'll pick center point right there. So very quickly we can reorient our pattern pieces just like that. So once we've oriented our pattern pieces, the process for from one person to another will definitely differ. ExactFlat does have a number of tools that will help in the patterning process. So for a lot of customers, depending on the complexity of the part, the more double curvature you have, the more strain or even sag you might end up with in your pattern, and you might need to add a relief cut or a dart. So there are a couple ways to do that. The easiest way is to simply do it on the 2D pattern, and ExactFlat has 3 different cutting tools. So our first one is our what we call our shortest path cutter, and this creates a cut along existing triangle edges. So for this tool, what I'm going to do is I'm going to turn our mesh edges back on, so EF toggle mesh edges, and now we can see the edge tessellation. So I'm going to zoom in on this piece here. These pieces don't require any kind of darts or relief cuts, so I'm just going to show you, then I'm going to undo the cut. But we'll start the shortest edge cutter, and it asks you to pick a starting vertex, so I'll pick one here. And as I move my mouse around, actually I'm going to use a different piece because red or highlight on the red piece is a little difficult to see. So we'll go ahead and we'll try this one here. Oh, that's not very easy. We'll try the blue one here. So I'll pick this as my starting vertex, and that's a lot easier to see. So we can see an orange highlight being created, and this is showing us exactly where our cut is going to be placed. So top to bottom is not going to work well, so I might want to do left to right. And very quickly I can create a cut, and in this case I cut the piece right in half. I'll go ahead and I can either undo that, or I can just use our delete cut to delete a cut. But cuts don't have to be placed all the way through a pattern piece. I can, for instance, create a cut that starts there and ends there, and now I've actually have a cut in there. So if I were to do something like, for instance, pelt, looks like that one cut all the way through. So we'll go ahead, we'll delete that cut, and we'll do it again. And we'll delete that one as well. So if I were to, for instance, we'll smart fracture this one again. There we go. And if I were to cut this piece, we'll say a cut from there to there. And now if I go ahead and pelt it, it's very subtle, but we can see we've got a split right through there. So we don't have a cut all the way through. And if I were to optimize this now, again, we'd be optimizing it with that cut in place. So I forgot to select our carbon fiber material here, but this is just for demonstration, and we're not going to be accepting this final pattern. But so I'll go ahead and I'll stop this right here. And again, if we zoom in, we can see that it's optimizing with that cut. So in the case where you have excess sag, what the cut will do, or the dart, is it's going to expand outwards, so you're going to be removing material there, and it's going to tighten it. If you have excess strain in a part, you might want to cut your part all the way through, split the piece in half, or you might want to physically cut out a V or a piece of material and have a separate piece that fits into that one spot just to relieve the strain. So we might want to create another cut over here, starting there, going to there, and then I'll create a last one there. So just with by creating 3 little cuts, I was able to extract a portion of the mesh. And in the case of a very high strain area, this method allows you to create a small little patch that can then be optimized and fit back in. So what we're going to do is we're going to heal these pieces. So we're going to delete the cuts and bring them back together because we don't actually need those cuts to be there. So once we have our pieces in the correct orientation, most important thing with composites is the grain direction or the fiber direction. So we can specify this using ExactFlat's grain line tool. So just by clicking this icon here, we can go ahead and start adding a grain line. So for these pieces here, we know they run perfectly horizontal. So these edges here, I know are perfectly horizontal and should have the grain line. So I can do this either on the pattern, or I can go back to our 3D reference model and I can create our grain lines on the 3D reference model. For this part, I'm going to go ahead and just do it on the pattern though. So I'm going to make sure I select an edge right here, and we've added our grain line. Part of our grain line tool is our global target strain. So we're not actually going to strain our pieces. We don't want strain on these ones. So we're just going to go ahead and click OK. So I'm just going to right click my mouse again to repeat the grain line command, and I'm just going to go ahead and finish adding grain lines to the rest of these pieces. For these ones here, because we want these at a 45, we're going to pick any edge along the edge here, and this is going to act as our grain line for us. If we accidentally make a mistake and place a second grain line on the same piece, that's not a big deal. It's just going to remove the first one and move the location of the grain line. I'll just do a quick visual glance, make sure that all the pieces have a grain line, and they do. So at this point, because we've added a grain line, it's probably a good idea to optimize again. Because of this reason, it might be better to add your grain line before optimizing the first time. So in that case, it's probably easiest to do it on your model. Because optimization doesn't take a long time for this part though, we're just going to go ahead, we're going to optimize it again after adding our grain line. So we'll select our carbon fiber material and we'll go ahead and click OK. So optimization is going to proceed extremely quickly here because our pieces, except the middle one here, we're already optimized. So because our grain angle has changed, we might notice a slightly different shape here. Grain angle does play a role in the optimization, the mechanical properties of the material. So we may end up with a slightly different shape. We're spending more time on this piece because we did pre-flatten it again. We did introduce some cuts that we had removed, so we had to re-optimize it back again. But all the other pieces here are progressing quite smoothly. So optimization is complete with all our grain lines on there. So what we'll do is we're going to turn off our mesh edges again, EF toggle mesh edges. So at this point we can view our strain on our pattern pieces, and we can visually tell because we've got predominantly white pattern pieces with only a little bit of cyan. That's indicating to us that we've got under that color of cyan is probably around 2% strain. Depending on your material, that may be acceptable. If not, you probably have to change your cut locations and try flattening again. But color is the primary way that we tell or judge the quality of the pattern. So the closer to white it is, the better. And of course, the legend can be modified. So if you have different needs from your ExactFlat legend, you can definitely modify the strain values and the colors. We just click the options button here, and from here we have access to all of ExactFlat's options. So we can change all the highlight colors and DXF export options. Our strain legend is right here, so the default legend is set up like this, but we can, for instance, change it so anywhere from 0 to for instance 4.9 might be white, and then 5 right on the nose might be red. So depending on your needs, you can configure the ExactFlat legend to work for you. But with the default legend, the amount of color just indicates the amount of strain being produced on the pattern piece. At this point, we can go ahead, we can create a DXF of this pattern piece. So when using ExactFlat, I'm just very quickly going to go ahead and reorient this pattern piece in the middle there. So we can create a DXF using the ExactFlat DXF exporter. We just click the DXF icon in the patterning tab, and that's going to open up our DXF exporter and allow us to choose a place to save this file. So this file came from our Harley Davidson model here, so we're going to change to our video folder here, and we're just going to call this fender.dxf. So we'll open up fender.dxf. We're going to open it up in another copy of Rhino, and we'll just have a quick look at the DXF here. So I'm just going to drag it onto screen. So we can see in the DXF that we've got a bit of different information here. So I'm going to maximize our top viewport. So most importantly, we have the cut perimeter of the pattern pieces, so we can see where all the cut lines are supposed to be. We can also see a gray highlight on all the pieces, so this indicates the grain direction of the material for these pattern pieces. So for these three over here, the grain direction is all predominantly horizontal. The grain orientation for these pieces over here is all predominantly 45, and that's because we selected edges on a 45. And for these ones, the grain angle is all horizontal. So more importantly, the grain information is all on separate layers from the cut line and seam line. With ExactFlat, we always get a cut line and a seam line, so you can optionally add a seam allowance to your pieces. So if you want excess material around your pieces to make sure you've got a really good fit in your mold, then you can add an optional seam allowance, and in that case you would actually see an offset edge here representing your seam line. But with ExactFlat, you always get a cut line, you always get a seam line. You can simply turn the seam layer off when you import it into your cutting table software. Most table software has a list of layers and asks you what you want to do with them. So there's ways to deal with that in all cutting table software. If your cutting table doesn't have that feature, then what you can do is you can just bring this back into Rhino, and you can simply delete the layer. So we can block edit our piece, block edit, and we can simply select the grain line and we can delete it. And it's as easy as that to get rid of the grain line. So we'll click OK to save our changes here. So it's very easy to make these kinds of changes to your DXF, but most cutting table software does have the ability to turn off the grain line or do nothing with it. So you can either remove it in Rhino, or you can simply not import it in your cutting table software. But the grain line is there for nesting purposes. If you want to bring this into a nesting package, then you can use the grain line to indicate the grain orientation of the piece. And depending on your material, you may want to specify no rotation allowed at all, or 180 degree rotation, or even 90 degree rotation in the case of a cross weave. So we'll go ahead, we'll close that, and we're back to our pattern. So to create a ply book from this, we can switch over to the documentation tab. And before we go ahead and create the ply book, what we're going to do is we're actually going to turn off the ExactFlat model and the ExactFlat pattern, and we're going to work with our original meshes that we created to create our ply book. So we're going to make the fender the default layer again, and we've got our meshes down there. And we've actually turned off our model and our pattern layer. And what we're going to do is we are going to select our meshes, and we're just going to move them up to a different location here. You can create a copy of these as well if you don't want to move the original, but ExactFlat does have a reference copy, so we can turn on our ExactFlat model, and we've got our 3D reference mesh right there in the same spot. But in order to create the ply book, we want to preserve the actual colors. And we're creating this mostly just to show how all these different layers go together. So we're going to create a copy, and we're going to move them off up here. Next, we're going to actually create some separation between the pieces. So we're going to select our outer layer, our A layer, and we're going to move this off to the side. When doing this, it's often easier. We're going to switch out of our top viewport. We're going to go into our perspective viewport, and we're just going to click the zoom extensed icon. This makes it a little easier to select your pieces, and what we're going to do is we're going to rotate under to our C layer, and we're going to select all these pieces, not that one. And we're just going to move them off to the side over here. So we're just trying to create some physical separation between them here, and what we're going to do next is we're going to use Rhino layouts to basically create or insert pages into a PDF. So we're going to use the actual model data here to act as our layup schedule or ply book. So we've got our 3 different layers from left to right. We've got our layer A1, 2, and 3, B1, 2, and 3, and C1, 2, and 3. So we're going to start with our first layer. So we're going to start with A. So we're going to select these pieces, and we're going to zoom to selected. So that's this icon right here. We're just going to zoom to selected, and we're going to line them up, and we're going to get this into a good view. So you could do top on, you could do kind of at an angle. It's entirely up to you how you want them laid out. If you're laying this down into a mold, you might want to start with your well, A would be the bigger layer. You might want to do them inverted like this. So it really depends on your needs, but the most important thing is we're going to start with our pieces. We're going to create, we're going to rotate our camera around and get a view that we really want to keep. And what we're going to do is we're going to, first of all, we're going to create a construction plane. We're going to move back to our piece creation tab here, and we're just going to create a new construction plane right along the view. The reason we're doing this is we're going to place our title and annotations and everything on here, so we really want these to be placed exactly where we see them. We're going to move back to our documentation. So now we're going to create some text, and our height is actually in paper space. So we might want the height of our text to be 15 millimeters, and this is going to be layer A. And when we click OK, we'll just place our layer title right up there. Next, we can use leaders to indicate the name of the piece. So we're going to use our leader command here, and we'll pick this piece right here. And this is going to be A1. And again, our height is always going to be in paper space, so we might want to do 8 millimeters, or we'll do 10, 1 centimeter tall, just so it's very visible, very easy to see. And we'll click OK. And we're going to repeat this process for this piece over here. And this is going to be A2. I'll make this 10 millimeters. Sorry, this I believe is A3. So we're going to double click this. We're going to edit the title for this piece, and we're just going to change the title to A3. And then lastly, we'll come over here to this piece down here, leader, and we'll select a vertex. Just bring it up here. We'll press enter, and A1 and 10 millimeters. We want to make sure we get the correct text height, otherwise we're not going to be able to read it. And now what we can do, I think I'm getting ahead of myself, we're actually going to select all this here, and we're going to click this button here that says new layout, and this creates a new layout or a new PDF page. So when we go to print this as a PDF, every single layout is going to be compiled together as a single page, and we'll end up with a single PDF that has one page for every single layer. So we'll call this layer or layout layer A, and we'll go ahead and click OK. So once we're in the layout view, what we want to do is make sure we go to our detail view. We don't want our perspective view at all. And what we're going to do is we're actually going to have to repeat some of the work we did here. I made a mistake. When we do our labeling, that should all be done in our layout here. So what I'm going to do is I'm just going to orbit my mouse or my camera here, and again we're just going to find the view orientation that we want. So this piece is A3. We're going to flip this around. We've got A1, A2, and A3. So we're just going to rotate, and we'll make this fill up the view. And we'll go ahead, we're going to once again set our construction plane to the current view. That way when we create our annotations, when we create our leaders and our text, it's all going to be right on top of or perpendicular to the camera. So we'll go back to our documentation tab, and we'll create our page title. So this is going to be layer A, we'll set a height of 20 millimeters. And now we can just place this right here at the top. And now we're going to go ahead with our leader. So we'll start down here, create a leader right there. And this is going to be A3, 10 millimeters. We'll right click to repeat the command. We'll do it down here. And this will be A2, 10 millimeters. And lastly, we've got A1 right over here. A1. So I forgot to change the text height. We can't actually see the text, so I'm just going to double click on the leader. That's going to open up the editor, and now I can change this text height to 10 millimeters. There we go. So because these layouts are essentially just Rhino views, we can use any of the Rhino commands that we want. So for instance, we can turn our grid on or off by using any of the Rhino tools that we want. So I'm just going to type in grid, and I'm going to turn, we're going to turn the grid off, we're going to turn the grid axes off, and we're going to turn the world axes off as well. And we're going to hide that from view. Lastly, when we're done with all our labels and page title, what we're going to do is we're going to click the down arrow up here, and we're going to go back to layout view. And that's just going to hide the rest of the stuff. What we can also do is we can set the shading for the viewport as well. So again, we can just use the Rhino icons up here. So we're just going to go to shaded viewport, and so we'll go back to detail, and now we can go shaded. Now we go back to layout. And this just makes it a little easier to identify the pieces. Otherwise, we're just looking at a transparent wireframe. So we'll repeat the process. When we created this layout, it created a new tab down here. So down here we have all of our views, including our layouts. So we've got our layer A layout. So what we can do is we can go back to our perspective view. We don't want to delete this or minimize it or anything. We just want to switch between our viewports down here. So we've got our layer A there. So we'll go to layer B right here. So what we're going to do is we're just, instead of doing our annotations here, we're going to create a new layout. So we're inserting a new page into our PDF, into our plybook. And we're going to call this layer B. So first thing we're going to do is we're going to have to adjust our camera angles. So we're going to click the down arrow. We're going to go to detail or top view. This allows us to pan and move around in the environment. So we're going to, just by holding control on the keyboard and right mouse, I can zoom in. If I want to be able to orbit or rotate the camera, we have to use the orbit command up here first. And now I can just rotate this around. So we're going to switch it around. So we're looking down and into it, and now we'll go ahead and start laying this. So actually I had it right the first time. We're going to rotate it up this way. Now we've got B1 at the top, and B2, and so on. So once you have your camera how you want it, I might want it like this, we can go ahead and we can start doing our documentation process. So the first step is, again, always we want to create a construction plane perpendicular to our current view. That way when we create our text, it's going right onto a perpendicular view. So we're going to create our construction plane there, and now we're free to create our page title. So this is going to be layer B, 20 millimeters. And I'll just go ahead. I'm going to quickly add our annotations here. So that was text. We want our leader. So I'm going to create a leader here. This is B1, 10. B2. B3. So one thing we can do is we could probably change the Rhino leader styles, so the text and height and everything is always already preset to, I think this is B4, to 10 millimeters. That way we don't have to change it every single time. And this is going to be B5. And lastly, we have B6. And lastly, we're going to turn on our shading, and we're going to use the grid command. We're going to turn off grid lines, we're going to hide major axis, and we're going to hide the world axis. Lastly, we're going to switch back to our layout view, and we've got another page. So we'll go back, we're going to create a new page. We're going to insert a new layout here. So we'll insert layer C. And first thing, we're going to go back to our top view. So the process is exactly the same. These are our C pieces over here. So we'll select these. We can even use the Rhino zooming command. So we're going to zoom to selected here. And we will orbit around here. So we've got C1 at the top. And we'll zoom out a little bit. Very similar to our last piece. So for this one, I'm going to try to bring it perfectly horizontal, and we'll just move that over to the side here. If you wanted to add any kind of title block, you could do that as well. You can even save your title block as a template, and then you can just import it into view here and fill out your title block information as well. So there's lots of options for your documentation here. So right now we're going to go and we're going to set a construction plane perpendicular to our view. Now we can go back and create our page title, layer C, and we'll do this as 20 millimeters, and we'll just place it at the top. And the process is the same now. We're going to go ahead, we'll start with our first piece here, and this is going to be C1, 10 millimeters. This is C2, 10 millimeters. Next we have C3. And C4. So as I'm creating these leaders, it's automatically snapping to the vertices. Again, I can hold Alt to temporarily disable the snap, and then I can place my leader wherever I want, including right inside of a triangle. So here we have C5. And C6. And lastly, we have C7. So I'll just center this a little bit more. We'll adjust our layer title. We're going to shade our viewport. Use the grid command. We're going to turn off the grid, major axis, and world axis. And now we'll go back to our layout view. So at this point, we've got our different views, and we can switch between them. Layer A, layer B, and layer C. And we can actually create a PDF of this simply by printing the document. So we're going to click the print icon, and from the printer list, our destination, we're going to make sure that we choose PDF. So in this case, we're going to choose Rhino PDF. And the most important thing here is our view and output scale. We want to change this to all layouts. Now we're printing all of our layouts here, and our scale, we're going to fit this to paper. Scale to fit. And then we can turn on or off different options depending on your needs. So if you have a black and white printer, you can change a lot of different options here. So for this one, display color would be best. That way we're getting the color of the mesh printed as the tessellation. But if you don't want that, we can always come down to visibility. We can turn on or off different options. There's lots of things that can be done in the print dialog, but the most important thing is that you print all layouts. That way all of your layouts are being placed into the DXF. So we'll go ahead and we'll print. And I think there's a small mistake there. So what we're going to do is we're just going to do this again. Instead of Rhino PDF, I'm going to select Adobe PDF. And we're going to go to make sure that we've got our letter paper. Portrait. We were set to landscape instead of portrait. So we'll always make sure we're set to portrait. Now our preview actually looks correct as well. So again, we're going to make sure that our all layouts is selected, and then we'll go ahead and we'll print. I'm just going to choose our location. And there we go. So I'll zoom to fit. So there we've got our layer A, layer B, and layer C. So to summarize, we started with our 3D model. We'll switch back to our perspective view here, and we'll zoom extents. We started with our 3D model. And if we go to rendered view, we can see we've got a beautiful 3D model here. We started with this. We'll turn our fender back on. And we selected the fender here. Actually, accidentally, we moved the fender, so it's not right where the bike should be. So we started with the fender, and we started with the bike. We isolated the fender, brought it onto a separate layer. We assigned, we created offset layers, we split it up, and then we flattened all those layers to produce our flat patterns. Thank you for watching.